Right, hello and welcome back to another video. This week we're going to be having a look at how we can constrain our particles to a specific bounding box around our emitter. This actually came in as a question from one of my viewers, so big thank you for sending that in. And I'm just going to do a little diagram to start with, just to explain what the issue is that we're having here, and hopefully that'll help us kind of show the direction of how we might sort of solve it. So very common in open world games. If you imagine here our player character in an open world landscape environment, it's very common if you have sort of particle effects, rather than filling the world with particles, obviously it's open world, it might even be procedural, so rather than another color here, rather than sort of filling the world with the particles, we attach them to the player. So if you could imagine something like rain particles, you don't want to fill the whole world, instead you attach it to the player position, and as you run around through that you're getting your rain falling and it feels like the rain is everywhere. Now something like rain, that works really well. It's very fast moving, there's no lag on that as you're moving around. Obviously you don't want to attach it directly to the player, you want it just to be spawning around them, otherwise it'll look like it's moving with you as you move. But this sort of fast moving particle works really well. But what happens if we've got something like sort of dust motes making a horror game? You want this nice sort of dusty atmospheric environment. Well, that's great if you move the player around, though. What's going to happen is you're going to walk outside of that volume. If I just go back to white here, player moves along, they're going to walk outside of that volume, and the dust motes are going to take a while to spawn and kind of build up in the area. So instead, if we write a system, what we're going to do is we're going to actually build a sort of box around our player. So I'm going to define some edges and say basically if the particle is outside of this box, instead of being here, move to be this side instead. And that's what we're going to do. I'm going to build that up as a custom module. So it's just going to take a distance from the player, or a distance from the sort of origin of our system. And if it's outside of that, just wrap round to the other side. So here we have the finished thing, and I'll show you how we make this in a second. But if I select this, if I move it along this axis, I haven't set this up, and you can see as we're moving along, new particles are spawning in behind us. But there's this lag, and we're not really surrounded by the dust motes that we want to be. If I just reset that, if I pull the other way, you can see we've got the effect that we're after here. So every particle, as it sort of moves across from one side, gets sort of respawned, not respawned, but actually teleported. So actually just move from one side to the other. So if I quickly click play, here we have our player character, and again, same thing. If I run sideways, I can very quickly run outside of the box, and there's a little bit of a lag and delay for those particles spawning in, which, I mean, might be okay. Again, fast moving particles going to work fine, but for very slow moving kind of atmospheric things, not so much. But if we run this way, we're popping out behind us and popping in front of us, and we're never able to sort of leave that volume because it's moving around with us. So really nice little feature. So how do we do it? Well, I'm just going to start with a simple system. Start with a Niagara emitter using the hanging particulates template. Give it a name that makes sense. I'm just going to upscale this a little bit. So by default, these are a bit small. Make them nice and big so you can see what's going on. And then we'll obviously be able to adjust that down again later. So to do this, everything else I think is going to be fine. We're actually going to go over and make a custom module here in the Scratchpad. For those of you new to Niagara, Scratchpad allows us to sort of test out little local modules, and if we like them, we can save them out and kind of make them their own module that we can then sort of refer back to in many cases. But to start with, we're just going to do it here as a custom module here in the Scratchpad. I'm going to call it, keep to box, something like that. Now, I'm not going to go over the basics of Scratchpad here. Hopefully you've had a bit of experience of this before, but as a very quick kind of overview, we have our input maps. This is all the data that exists in our particles up until this point. We're going to extract out some data, do a little bit of logic, and then just pump it back in again. So the three things that we're going to be able to, or we're going to need, is the existing particle position, and that's a variable or some data that we can get from our input map. We're going to need our engine owner position, and what this refers to, if it's the system on its own as an actor in the world, that'll be the system location, or if we attach it to our character, that's going to give us the character location. So it's the position in the world where the system is. So if we go back to our sort of diagram here, that's our engine owner position here in the center where the character is, and then our particle positions obviously is per particle, and then the other thing we need is this distance here, so we're going to define our own value to be able to do that. So if I go in here and add a new one, I'm just going to type in a float, and we want a new input float. Down in the side here, I should be able to find it. I'm just going to rename that to box size, something like that. It's not the easiest thing to see here, screen space wise. Try and get myself a bit more space. So what are we going to do? Well, we want to do basically an if clause. We're just going to take our particle position, and if the particle position is greater than the center point plus the offset, just move it to the other side. And so let's build that up. So I'm going to take my particle position. This is a vector, and we're going to have to do this in separate axes. So we're basically just going to consider the x-axis first, and then we can add the y-axis and the z-axis if we need to. It's all the same logic, just being done in different directions. So we've broken out our position vector, and I'm going to break out the owner position as well. So this is our particle positions. Oops, let's turn that off actually, makes sense, not going to need that. So this is our particle position broken out, this is our owner position, and then our box size. So if we take our engine position and add our box size, so just a simple add node, this is our kind of positive boundary on the positive x-axis, and then if we do an if, I'm going to add a float input to this. So what this is going to give us is, oh no, it's not. Yes, that is right. So we have a condition here, and we want to do a greater than. So we're comparing two things. So if the particle's x position is greater than the box plus the offset, or the edge position, if it is, well, first of all, if it isn't, let's make sure I try and get these the right way around. So, well, let's just test that first. So if I do a particles position output, I'm going to have to do a make vector here as well. Turn this one off. So if the particle is greater than this, we want to move it to the other side. Well, that's the center point minus the offset. So we know if it's greater than the offset this side, we want to move to minus the offset on this side. So if I take my x value and then just do a subtract, and we're going to subtract our box size. So if it's greater than, so A, I believe, is true, so we'll plug this one in first. So if it's greater than, move to there, and if it's less than, stay where it is. And that's going to become our new x position. And I'm just going to wire through the z and y positions. Just apply this. Won't have done anything yet, because although we've made our scratch module, we haven't applied it here. And it's called keep to box. I'm just going to put this up here. Ooh, well, it's definitely doing something. I think I've got my true and falses the wrong way around, and so it's, oh no, that's not true. I've just not set my box size. So box size of 0 is going to push it to the side here, to the origin. If I do a value of 250, my initial box location in here is about 400. So I'm getting particles spawning outside. And let's have a look at this and see if this is working. So I'll create a system for it. Oops. And what we should find is as we move in that direction, it's taking the particles and just moving them around to the other side. Now obviously this is only doing one direction at the moment, We've only compared against our positive x, but it's very easy to set up the same logic for the other side, so let's do that as well. So if we do first an if condition, if it's greater than the positive side, so as I say, if it's greater than the positive side of this side, move it to here. Well, we just do the same in reverse. If it's less than the negative side, move it to there. And we actually already have all those numbers. So we'll do another if condition and say, rather than the greater than, we'll do a less than. Oops, let's not copy that one. And Scratch modules can get a little bit messy. There's a lot of wiring. That's why I always like to draw a little diagram or kind of really plan out what I'm doing beforehand, because it's very easy to get kind of lost in the numbers and the wiring here. So how are we doing this? Well, I'm still comparing my x position, and in this case it's not my initial origin plus the box size, it's that minus the box size. And so if we're less than the negative, if that's true, let's just make sure I get these the right way around. So before we were subtracting, so in this case we want to add, and if it's not true, we just want to pass that data through. Hopefully I've done that correctly. If I just apply, compile, check in the world. So if I move x, it goes one way. Oh, no, I've done it wrong. Why have I done that wrong? Just make sure that everything is applied and compiled. Very easy when you're working in, there we go. Very easy when you're working in Niagara, especially when you're working inside a Scratch module, that you need to make sure that every stage has been applied. So if it ever doesn't quite work, don't assume it's done it wrong, just double check that you've done everything and applied it all correctly. And there we are. Now, if we're greater than the origin plus the box size, we subtract the box size. And if we are less than the origin minus the box size, we add the box size. And that's our kind of logic to this. If you like, spread this out a little bit, try and make it a little bit easier to read. And obviously we could do the same thing for our other axes as well. So same logic, just plugging through on the y. In fact, let's do it. So let's just copy and paste these nodes. Try and arrange this in such a way that's a bit easier to see. Oops, let's bring that one up. So as you can see, it does get a little bit messy. Just remove those two, that might help a little bit. So we're comparing initially the y particle position. Is it greater than the y plus the box size? And then also comparing the y less than to the y minus the box size. And then this is the same, and that becomes our y value. Oops. And then our z value just comes plugged through from our particle position. So apply here, and that should now mean that, oh, I've done something wrong. What's gone wrong? We've got our order incorrect. That's interesting. Let's open that up. Make sure that we're working in the emitter, not in the system. So if y, oh, float b is not connected. There we are. So we weren't actually passing through our initial position. So that should be that one. Just keep looking at this right. That should be x. That should be y. Yes. Apply that. And there we are. So we move left and right. Our particles stay constrained to our character. If we move up and down, they do as well. Obviously, we haven't done the z-axis, but we could just copy that through again. So if we're happy with this as a module, we could create an asset from it, and that would then live in our project, ready to be used for lots of different things. And let's do that. So in my tutorials folder, it's called particle player box. I'm going to call this an M for module. Keep to box. There we are. If you want this to be available to all modules, there's an option in here for your library visibility, whether it should be exposed or hidden. So that will then just make it visible in in your sort of library here. So if I type in keep to box, see it's got this little star that's showing that it's not exposed. If I save this here, make this exposed, apply, save, replace that with nm keep to box. There we are, and that's the one that we've set. We do need to set a default value for our box exposure, so we could probably do that in here. So our box size, default value, set that to be something like 250, just so it doesn't fail on that first add. But obviously we can see that as well. Cool. Now you might notice occasionally we're getting this flickering. That's obviously the edge condition kind of becoming true and false. We could try and change that with a sort of a little bit of a buffer zone, and we could say, right, well, if it's greater than this side, move it to 90% rather than right to the edge, and do that on both sides, and then it would have a little bit of a buffer zone. But actually there's another issue, and so we're going to do something that's going to fix both of them. So if I just click play, this is using the previous one but shows the same thing. If I walk forwards, we see we're getting quite bad popping as these particles are popping in and out. Fine, it does what we want, but there's also this big visual bug. So rather than leaving it like this, I'm just going to add another module or another little sort of feature to this, and I'm going to do a normalized distance. So if I'm going to create a new parameter, set new or existing parameter directly, and I'm going to create a parameter which I'm going to call normalized. Oops, I'm going to create a float. There we go. And I'm going to call it normalized distance. And what I want is I want a value which is basically a percentage of how close we are to the edge. If I'm at the center here where the player is, I want a value of 1, and then a value here at the edges, I want a value of 0, 1, 0, 1. Or the other way around, it doesn't really matter, 1, 0, 1. Just so we've got a sort of scale of how close we are, and then we can use that to fade our particles away. So first thing I'm going to do in here is actually just do a normalized distance range, and that's the thing we can plug into our input, and it's basically the same kind of thing that we just did. So the start position is going to be our particle position. That's where our particle currently is. Our end position is going to be our engine owner position, and then the distance is going to be the same value as we've got in here, this box size. And so we'll put this down as 250. And what that will do is give us values from 0 to 1 based around the center to the edge. If it's the wrong way around, we can always swap it, which is the start and end. But what we're going to use that to do is scale our particles. Oop. Scale sprite size. So there's already a sprite size scale in here, and this is doing it over the normalized age of the particle. So how long has it lived? Scale in, scale out, that's doing our kind of like our fading. And this is going to be doing the same thing, but based on that distance value that we've created. So first thing I'm going to do is a float 2D from a vector 2D from float. That means we're going to get uniform scaling, and then I'm going to do a float from a curve, and then rather than using the age of the particle, I'm going to use this normalized distance that I've created. Normalized distance range. So we could have done that logic in here, or we could have created the particle parameter, which is what we've done. Doesn't really matter. And what we've done now is the particles that are at the edge of the box, as well as being kind of teleported across the other side, they're actually scaling off to 0 at those edges because of this curve. And we can change this fall off if we wanted, if we only wanted to have a sort of slight fall off at the edge. Obviously you've got full control over that with the curve there. And what that will do, if I save this and play, will mean that the particles at the edge of the box, oops, obviously that was the wrong one, let's use the one that's over here. The particles at the edge of the box are scaled down to nothing. So as well as kind of flickering back and forth, or to stop that flickering back and forth, and to stop that visual popping, we now have particles. And wherever we move this to, we're going to have a nice volume of particles around, but we're not creating particles everywhere. It's not a huge volume that gets revealed, which would be another solution. it's the actual particles that's sort of fixed around the emitter, and when you move, it moves the particles with you. Cool. Hopefully that was helpful. Thank you very much for sending that question in. It's quite an interesting one. Not a problem I've had before, but hopefully quite a cool and interesting solution. As always, big thanks to all my patrons for supporting the channel. Hopefully it was interesting and informative, and I will see you all next time.